You've probably seen the headlines. A historic Super El Nino seems to be 100% certain at this point. How does it really affect winter time for the Willamette Valley? I'm here to talk about what normally happens during a Super El Nino. This does not replace my winter weather prediction that comes out in October, and my regular method will still apply there, as no 2 years are 100% alike. They're similar, but not alike. Exactly. And also, as with anything else with oscillations, these are just guides, not rules. Always be prepared for any extreme weather events. So, for anyone unfamiliar with what El Nino is, it's above normal temperatures in the central tropical Pacific. We're specifically looking at the Nino 3.4 area as it's known. This is not drawn to scale for the record, and that's about right here. Nino 1.2 is further east, and Nino 04 is further west. So if it's above normal temperatures here, that means we're in El Nino. If it's below normal temperatures, that means we're in La Nina, to put it in simple terms. Now, there are two main ways to classify it. The first is the relative anomalies, and the second, it's just the regular anomalies. I'll go into that here in a few minutes. Also, if you're curious about what all this up here means, that is related to a different oscillation, the Pacific Decadal Oscillation, which I also use for my long-range predictions. That will be linked in the end cards and in the description below, as I have a video from about 2 years ago going over that. So in terms of what happens during El Nino, this is NOAA's official graphic on the continental US, Canada, and Alaska's effects during an El Nino. The entire northern, central, and western half of the US sees warmer than normal conditions according to NOAA. However, that line does end in the Willamette Valley. Also, you may have heard that it's drier than normal during an El Nino. That's not on NOAA's graphic, and that's not what my findings show on Super El Nino. So we'll get into that in a few minutes. If you go further south, it does get wetter and cooler than average once you start getting into the desert southwest, and especially along the Gulf. In terms of how strong this is and what really defines a Super El Nino, a Super El Nino is generally anything about 2 degrees Celsius or stronger compared to average, whether you use the relative average or the total departure from average. So terrible line drawn, I know, but gets the job done. This is the CFS model, and it's showing almost every ensemble member going above that 2 degrees Celsius line for at least a couple months. That's pretty good confidence that this model is thinking that we are going to be in a Super El Nino. However, I have noticed recently that this model has had a little bit of a cold bias. So let's take a look at a more aggressive model, the Australian outlook. It's showing the ENSO anomalies to be about 3.5 degrees Celsius above normal. And this is also relative anomalies similar to the CFS. And also for the record high for a relative El Nino anomaly is about 2.7 degrees Celsius, where that line is there. So this would be about 0.8 of a degree Celsius above that record if that were to verify. However, I have noticed that this model has a little bit of a warm bias the last couple of months. So I think it'll be somewhere in between. I think the all-time record is definitely in play. We'll figure out where it'll end up pretty much as it's happening. But the only thing we do know is a Super El Nino is almost a 100% certainty at this point. The latest weekly value was about a 1.5 degrees Celsius relative anomaly. This model was showing about 2.2 at this time for the record, versus the CFS showing about a 1.2 or so. Relative anomalies versus the original index, or raw anomalies in this case. The relative index takes the anomalies in the central tropical Pacific and subtracts the global mean sea surface temperature anomalies. It's the official index used by NOAA and the Australian Bureau of Meteorology. The original index just takes the raw anomalies and that's your value. It's easier for models to digest that, so most models do use this with some exceptions, like the CFS and the Australian model, though I have noticed more models are starting to jump on that bandwagon. So if you see a model map posted on social media, make sure you figure out which index it is using. Because if it's using the original index and it's showing 4 degrees Celsius above average, but the global mean anomaly is about 3/4 of a degree above average, suddenly it's looking record high, but not nearly as record high as it was before, using a hypothetical scenario in that case. There's also a different index that I use because one flaw about both of these is they tend to just use one sea surface temperature data set, and that's it. As reliable as they have become, there are some differences. I use what's called the Ensemble Oceanic Index, which is very similar to the relative index, but it takes a look at 32 different sea surface temperature data sets, some going all the way back into 1850, and takes the average out of all of that. So I feel it's a more accurate take on our ENSO status. I'll link that data set in the description below if anyone wants to take a look. So there have been 6 Super El Ninos in history. 2 of them were in the late 1800s, and 3 of them were in the 1900s, and then the most recent one in 2015 to 2016. There were 2 that were more borderline than the other ones, and that's 1888 to 89 and 1972 to 73. So, what happened during these Super Ninos? I'm going to frame this in the same way that I frame my long range winter weather predictions, doing it in the same 7 categories. So, let's get started. Major windstorms is going to be my first category in this case because I use this graphic at every winter weather forecast I've done for the last few years now, and it shows that if you want a major windstorm, you want it to be as close to ENSO neutral as possible. Once you're getting further away from ENSO neutral, the harder it is to get a major windstorm, and once you hit moderate La Nina strength or moderate El Nino strength, or greater, which is a degree Celsius above or below normal, then there's been no major windstorm noted in the Pacific Northwest. So that gives me very good confidence we wouldn't be seeing a windstorm regardless of any other oscillation. Now, onto the water year rainfall. As a note, PDX data goes back to 1872, so I can view every Super El Nino with PDX. For Eugene, data only goes back to 1892, so I cannot view the earlier 2 Super Ninos. For PDX, the 4 firm Super Ninos were all above normal precipitation. The other 2 were a little bit below normal, about 6 to 10 inches below normal. The numbers down here are not the normals used by the National Weather Service. This is a rolling 30-year median, so that's about an inch and a half below the actual normals used. And the reason why it's below, it's been consistently below, regardless of which 30-year period I use. And that's because it removes the outlier years, the very wet years. Like, for instance, 1877 to 78 was a very wet year. For Eugene, it was a little bit closer to normal across the board, with the exception of 1982 to 83, which was a very wet year for Eugene. For the lowest winter temperatures, the 30-year median at PDX is 23 degrees, and a Super El Nino hasn't really seen much difference compared to that. Unlike my winter weather forecast, I did not adjust the data back in the late 1800s, so take that with a little bit of grain of salt. The big exception was 1972 to 73, which had an 8-degree low at PDX and a negative 12-degree low at Eugene. That is their all-time coldest temperature, which kind of bucks the a traditional trend of La Niñas when you get the coldest temperatures. Otherwise, in Eugene, it tends to be slightly below normal, though 1997 and 98 was an exception, and with it being 26 degrees. Their 30-year median drops to 19 degrees, is as the coldest temperature of winter. For the temperature departure from average, this I did keep the adjustments that I use on my winter forecast, so it has been adjusted to the averages at which they occurred. So 1877 to 78, I'm using the first averages, is in this case downtown Portland used, which was 1872 to 1900. It was 2.5 degrees above average, which is pretty significant, but the record warm in terms of a Super Nino is 2015-16 at 3.3 degrees above normal. Pretty much every winter in both PDX and Eugene were above normal by at least a degree. The exception is 1972 to 73 because of that cold snap. Adjusted snowfall. Years prior to 1970, I've adjusted it so that it's a 4.3 inch average per year to make it more relative to what we experience today. A 4.3 inch average we have experienced since the 1970s. So in the earlier two Super Ninos, we didn't see a lot of snow, just one event, and that's it. In the case of 1877 to 78, there was a minor ice storm from Portland east. The big snow events were in 1972 to 73, with anywhere from about 4 to 12 inches in the valley, depending on where you were at, and 1997 and 98, which was a primarily Portland-focused event, but we did have 8.7 inches is there, and a moderate event in 2015 to 16. The median for Portland is 2.8 inches, and in Eugene, 1.9 inches. As a note, the data is missing in Eugene between about 1996 and 2011. So for simplicity, I'm using the median going back till the early 1970s when the snowfall averages became 4.3 inch average per year rather than the 30-year rolling median that I used before. And I'm using that for consistency between PDX and Eugene. In terms of when these wintry events happen, for temperatures, December of 1972, 5 out of the 6 Decembers were above average. Only 2 had cold snaps of any significant intensity. I'm calling significant 37 degrees or below for a high in modern times, or 35 degrees or below for a high in the oldest 2 Super Ninos. January was a little bit more of a toss-up. 2 of them were below average Januaries. 1 was within half a degree of average, and 3 were above average. But 5 of the 6 Januaries had a significant cold snap at some point in the month. Generally was in the first half. Granted, 1 was due to snow cover, not the air mass. So take that with a little grain of salt. Still, 4 out of 6 is relatively good odds for just looking at El Nino blindly. No February was below average, and there were no significant cold snaps in February, which bucks the recent trend we have seen of active Februaries, with a majority of our snowfall the last 12 years or so has been during February. The wettest times, November was drier compared to average, but December, January, and February was actually wetter than average. December had the strongest signal. It also had the all-time wettest December at PDX, which is December of 2015. January and February had a majority above average, 4 out of 6 in both of them, but not as strong of a signal as December. And for snow, all snowstorms occurred before January 15th. So if you get past that date, it's not looking likely you would see snowfall that winter. And except for December 1972, all snow events were quick hitters where it falls, stays on the ground for a day to 3, depending on how much falls, and then thaw happens not too long later. I did take a look at just strong Ninos and not Super El Ninos, and I found very similar rules as the Super Nino, where all snowstorms pretty much occurred before January 15th as well. And taking a look at the mountains, if you were a skier or boarder last winter, it was one of the worst years on record. Well, I got good news for you this winter. If you are going to at least the higher elevation ski resorts, it's looking like, okay, maybe slightly below average, but 80 to 95% of average compared to last winter, which was about 45% of average. That looks like it will be a good ski season. This is using the Timberline snow data, which goes back into the 1950s. And the worst year is 2015-16 at 145 inches, but all the rest of them were within about 6 inches of each other. Normal up there is 165 inches. So I did take a look at the worst years at Timberline, and I added in the QBO phase, which is another oscillation that I use. It takes a look at the stratospheric winds, whether it's going westerly or easterly. That's a TLDR version. If you want to learn more, that will also be in the end cards and in the description. None of these are Super Ninos. All of them are either ENSO neutral in the case of 2 of them, weak El Ninos in the case of 3 of them, and weak La Ninas in the case of 3 of them. So we're looking set for at least a respectable ski season. It's not necessarily going to be a banner year, though. All years were 60% of the median or worse are listed here, or 40% of the median are March 1st in the case of 2014-15, which that had a pretty good late season comeback. All Super El Niños since 1960 have been with the westerly QBO. Why that matters? Only 1 year on this had a westerly QBO, 1980 to 81. 2004 to 2005 did start westerly, and then flipped to easterly midway through the winter. So I like our odds at seeing a good ski season. But I don't rely on ENSO alone for my winter weather predictions, as I kind of hinted towards it's in my last slide. The QBO and PDO heavily affect our weather as well, and especially QBO, a westerly QBO tilts our odds towards snowier and slightly wetter than normal. And then on top of that, I explained this in my QBO video, but a westerly QBO with an El Nino, since QBO data became reliable, 77% of those saw median or better snowfall in Portland. If you flip that to easterly, 0% saw median or better. The PDO does run on larger timescales, but has similar guides as the stereotypical ENSO guide. So I'm saying stereotypical meaning warmer, drier than normal is El Nino, cooler and wetter than normal is La Nina. The combination of all data sets and oscillations creates the most accurate forecast, and even that's still only a guide, not a rule. For reference, the long-range forecasting industry average is 55%. My average since I started doing these in the late 2018, including 3 private ones that I had before releasing these on YouTube, is 65%. If I start doing QBO on day 1, I've done blind forecasts from reforecast from the beginning, and it would have improved my accuracy by about 6%. I do this for fun because I like doing this. Even though, again, it's not the most accurate. Analog years are key for an accurate prediction. If anyone's wondering, a pure guess percentage is 33%. So it's better than pure guessing. And in case you didn't want to watch the entire thing, this is the summary slide. Water year tilts above normal, no big storm expected for a windstorm. Above normal is highly likely for temperature departure, but toss up whether we get a good cold snap or not. Most likely that would be in the first part of January. I can't rule out December though. Ski resort snowfall near, maybe slightly below average. Valley snowfall, toss up. No hyperactive years though for valley snowfall, and that's defined as 12 inches or more. So that is going to be it for this video. I hope you learned something from this. My winter weather predictions, as usual, will come out in mid to late October, so stay tuned for that. And which of these years makes the top analog cut and which ones that aren't Super Ninos, if any, make the top analog cut. But until then, stay safe out there and take care.